And I will pass the floor over to Dom Saul, Chief Experience Architect at Akendi, and Kevin Bailey, President of Design First.
Welcome to day one to our workshop on designing for IoT. This workshop was a while in the making. We started out with a request. Adam came to some of us and said, you know, he's thinking about putting something together for IoT. And it kind of grew out of that. We kind of got carried away, and now we have a conference. But we really
We're kids at heart.
We are kids at heart. We like to play with stuff. One of the things that we wanted to do is make sure that you all had an opportunity to meet each other. Because Kevin's company, they're world-class in terms of product design, industrial design. They make some really cool stuff. If you've never seen the stuff that Design First has made, go on their website, check it out. Very, very cool stuff. At Akendi, we do interaction design, we do research, we do testing, we do strategy, we do innovation around user experience and customer experience. We've worked with Kevin, and we've worked with some of you, and one of the things that I noticed is that there's real world-class talent in Ottawa around IoT. So one of the things that I wanted to make sure that we do is to make sure that everybody understands that no matter what you're building, if it is IoT related, there is the talent in Ottawa here to be able to create and produce what it is that you're building.
Absolutely. And many, many years ago, there was a place, the land of Nortel, where we actually developed communication products, and we had to deal with the hardware, we had to deal with moving information up to the cloud, and then managing it, getting back to telephones. Nowadays, we're back together because there's a lot more of that going on in the IoT space, only now we've got displays on everything. It's a lot more complicated in terms of the user, what confuses them, and with a series of sensors now, the sensors can have a limited user UI, or they can have an extensive UI, or they can have nothing other than a light that tells you it's on.
Yep. So we decided to get together and put on this workshop to discuss with you a little bit some of the challenges that we face when we are designing products, IoT products specifically. We're designing products for usability. We're designing products that are, they're supposed to be easy to use, easy to understand. So I'd like to take the next couple of hours to introduce you to some principles of UX, of usability. You'll notice there's pencils and hopefully erasers and stuff on your tables. We're going to get you drawing. We are going to get you designing applications today. Akendi people, where are you? There's one. There's another. We're going to have people mingling around as we're designing to help discuss and understand some of the principles of UX that we're talking about. We have some Design First people over there. Hey, and they're going to be helping us too. One of the things that we really wanted this conference to be was hands-on. We wanted people to play with things, to touch things, to see things, so that they could understand that this is not a big, scary domain. There are people from all parts of the IoT spectrum here. There's hardware people, there's software people, there's chip people, there's industrial design people, there's software people, and UX people. Mix, mingle, learn.
Can we ask one question? Of the group, how many are hardware-centric and how many are software-centric? Just by show of hands, the hardware-centric people? So it's 5 or 6, and then the software-centric people is the rest? Okay. So we'll limit our conversations on hardware, or maybe you're interested in hardware. Just let us know. We want this to be a bit interactive, so ask questions.
It's all cool. I'm just going to introduce myself before we get into it. My name is Dom Saul, Dominator Saul. Like Adam said, I'm Chief Experience Architect at Akendi. And what I've done for the past 15 plus, I stopped counting at 15, but what I've done for the past 15 or so years is I've been able to observe sort of the evolution of design of technological products for people. So back in the day when we were designing websites, the first mobile app that I designed was actually an SMS app where you would send a text message to a server and it would answer you I won't tell you what year that was, but it was a long time ago. We want to be able to share some of this knowledge with you today.
On my side, I'm a little older than Dom. It doesn't show, I hope. But I'm 32 years developing hardware products, sitting and working with the connected hardware products. My company does somewhere around 80 products a year for companies around the world. We do some of those products here with companies in Ottawa. And I'm looking forward to this interaction because we're about a year and a half into developing IoT-based products that companies need. More than just beacons, much more interactivity, but this next 5 years is going to be very exciting for the hardware world. There's lots going on. There's numbers out there you may already be aware of, but 17 trillion by 2019 spent in this space alone, and billions of devices actually hitting the streets to inform us and create chaos in our lives, hopefully create simplicity if Dom and I do our jobs right.
Yeah.
Which one? Mine? Okay, I apologize.
It's a deep, sexy Kevin voice. So, what is the Internet of Things? First of all, this is going to be a discussion. This is not going to be Kevin and I talking at you. There are certainly people in this audience that know more than we do about certain things, IoT related. So, I'm going to ask you, what is the Internet of Things? No need to raise your hand, just shout it out.
Jacques, IPv6?
IPv6? .ca, yes. You're going to have to really shout it out, because taking stock of things talking to each other, like what, like cats and dogs, or? You want your toaster to tweet when the toast is done. Excellent. Yes. Pardon me? Connected devices. It's things that talk to each other through the internet, right? It's connected devices. And so it can actually be anything. And Jacques was right. The internet is this underlying network that allows these things to talk to each other. But it's more than just the internet. It is all sorts of different components. So you threw out a number, Jacques, 10 undecillion, I believe. Does anybody have any idea how many zeros that is? 37 zeros. Alvaro, you sure? You sound very, very confident that was 37. I have no idea. I know it is 2 to the power of 128, right? So by 2020, we are going to be able to have, with IP version 6, an IP address for every molecule on the surface of the Earth. That's how many IP addresses. Yeah, you're furrowing your brow like it sounds science fiction-y, but it's true. Every molecule on the face of the Earth could have an IP address under IP version 6. What does that mean? It literally means that things can talk to things. Your toaster can talk to your phone, but it can also talk to any other thing in the house. My shoelaces can have IP addresses, my shoes, et cetera, et cetera. The interesting thing about this, this development, it means that we can create devices that do things that we haven't even thought about yet, we haven't even imagined yet. Think of the way that mobile phones have transformed communication. Think of the things that we do with our phones now that before 2007 somebody would have laughed at. You know, my phone is going to track my heart rate. That's silly. But it's happening. So what is the IoT? It can be anything. It can actually help your cat and your dog talk to each other. It can tell you if you're exercising the right way or if you're exercising enough. It can tell you your air quality. It can tell you what your environment is like. It can be a creepy little weird robot that'll give you nightmares. It can be all of those things. This creates a little bit of a design challenge for us because it's not only the hardware that we have to take into consideration. It's not only the software that we have to take into consideration, but it really is all of those things that intersect. So when we talk about the Internet of Things, we're talking about the hardware. We're talking about the software. We're talking about the sensors. We're talking about the protocol. We're talking about the data. All of it comes together in the products, in the millions and millions of products that are going to evolve and be developed once we have all of these IP addresses. Right, Jacques? So, what are some of the challenges that we face? In terms of design, there are certainly software challenges, but there are also hardware challenges. I'm going to hand over to Kevin for a bit, if you're okay. No, drink your water. Where's the human layer? Oh, we're going to get to that. The human layer is, if this is a good question, a question we get often. If IP, sorry, you're in my head. If IoT is devices talking to devices, where is the human layer? Well, we have to configure those devices. When my toaster is going to tweet at me, how is it going to know which Twitter handle to tweet at? How am I going to input that information into my toaster, right? Think about it. Pardon me? It asks your phone, right? Who is this guy? But how does it know it's my phone? How does it get on my network? How does it get past my own personal security? So all of these things are the human layer. The information that we put into these devices, the information that these devices output to us, that's all the human layer. And not all of these devices are going to have very clear buttons and very clear screens that we can deal with. A lot of these technological advances are spawning new ways of interacting with technology. It's not just reading a screen and typing. Now we have gesture. Now we have things that are more predictive. So the human layer, I don't even think it's a human layer. I think the human interaction for IoT is very much saturated in the devices that we are creating. And more, they're kind of formless, shapeless things, but they require us to decipher how it is that we interact with them. And we're going to talk about that in a little bit.
And really, that's the heart of a good design, is to make sure that human layer it's easy to use, don't make me wait, don't confuse me, and it better be reliable. And the design teams that take that on have to understand that as the key driver to bring the technology together, and the software companies that are actually building the software so the whole thing works. So when I'm looking on my smartphone and I'm down in my basement and I'm trying to figure out why this new connected sump pump is going off an alarm and I'm not connected to the Wi-Fi, I can't shut it off because I can't get my smartphone to talk to the pump, we got problems. There's a certain component of every device that's going to be interactive in a connected world that has to actually have a good user experience around it, and it should be, if done well, connected with the user experience at the software and at the app level. So everything the user experiences in their different situations that they're using the products, it has to feel natural. And that's a hard thing to do. It's a more complex design process, and you need really experienced teams to make those trade-offs so that you do get that experience without spending 2 or 3 years in a trial and error mode.
So we're talking about sensors, we're talking about hardware, we are talking about protocols, we have this idea of the cloud, and of course access points. So the access points may be on the devices themselves, or they may not. The sensors talk to the hardware somehow talks to the cloud dumps data down to the access point, or data is taken from the access point up.
Can how many people have actually created something in software with Arduino, turned on some lights, done something at the experimental level with the hardware components? Just show of hands who's done it. So for the people that haven't, if you hold that for a second. So this is a 5-part purchased off the web. These are the components you need to build something in literally 15 minutes. Al didn't know anything about this about a week ago. Al's now programming and running these particular things. Easy to do once you know where to go and what to get. 3D printed part, a radio effectively that connects to a server that exists, a battery, some power management, and then you pick the device. We've got lights here, but you can control motors, you can control whatever you want. A small program available on the web. You're in there programming. If someone starts you out with a piece of software so you can just actually change some variables, we'll show you a demo in a minute about what that means and how quick and easy it is to do something. And that involves then, we've got the sensor being, actually we'll show you another example of a sensor in a minute, but you do need the hardware component, the connectivity of the radio. Obviously, once it gets to the cloud, somebody has to manage that data up there. There's existing companies now that manage it for you at a price. It's fairly pricey. When you get into production style stuff, it's something that's going to evolve into custom radios, cheaper alternatives. But if you're in a fool around mode, there's lots of stuff there out there for you to actually experiment and grow your knowledge so we all can get better at connected hardware.
Thanks. So, what's big data? Aggregated data? A lot of data? It's very, very large data.
Giant ones and zeros.
Yes, giant ones and zeros. How many people have heard the term big data? Almost everybody. What is the cloud? Jen? Storing your information on the internet. So your internet is somewhere out there. Just an aside, my mother does not trust the cloud. Who knows? So we got big data, we got the cloud. Wi-Fi? Pardon? And then we got money. Well, we're going to get into we can get into cryptocurrencies if you want, but that's a whole other conference, I think. Oh, yeah. Well, that's a philosophy conference also. So there is the money aspect, right, where all of this data is generated and then it's sold. And there certainly is that money aspect of IoT where we may not know what's got a sensor in it and what doesn't, and what's collecting data on us and what isn't. And when somebody takes that data and sells it, well, that's a whole bunch of problems. So we hear about cloud, we hear about big data, we hear about these things, and we have for a couple of years now, but they really come together in IoT because we have all of these devices that are generating more data than we've ever had to deal with before. So to Alvaro's question, again, the human layer is, what do we do with that data? When we have so much data that is coming down that we don't really, it's kind of like drinking from a fire hose. Again, we have to look at how that data is going to be used, how it's going to be visualized, how it's going to be represented. All of those things are things and challenges that we face. This concept of IoT is really tying together a lot of the big technological trends that have happened, where we have hardware, we have the cloud, we have sensors, we have all these access points coming together in a way that's really interesting, that's really neat, that's really new. So the cloud interacts with hardware connections. So let's talk a little bit about that. We got Wi-Fi. We got WiMAX, we got Bluetooth, we got NFC, we got low-powered Bluetooth, all of these things. Why are there so many different ways of machines talking to machines? Yes, because we're not communists. The free market system. So there's different standards that have emerged. Is it going to be a VHS Betamax kind of thing? This is my question to you. Now, I know who's young and who is older because some people are looking at me saying, Betamax, I've never heard of that protocol. But there's certain people that know exactly what I'm talking about. So is it going to be a VHS or a Betamax kind of thing? Are we going to have an evolution towards a standardized set of protocols? And if so, when and how and why? These are still questions that we're struggling with, we're trying to answer right now. These are more hardware questions.
And the answer is, who really cares what the wireless standard is? As a user, you don't care. There's going to be a day where we just don't care. It's just we're in the middle of a migration of the world being populated with different companies bringing out different standards and different strategies, but ultimately some types of radio signals don't get into buildings, and so you come up with a cheaper solution to do that. But ultimately, this whole world will be wired in some wireless way where we as users don't care. We really don't care. We want the devices to work. We don't be running around figuring out Wi-Fi connections and signals.
Exactly. So Kevin talked to you a little bit about the fish, and I talked a little bit about some of the components of IoT. So I wanted to make it a little bit more real for you around how the fish and the examples that we are going to be using actually map onto that IoT diagram that I talked about before. So you may not be able to see this, but that's Tom Mulcair, that's Stephen Harper, that's Justin Trudeau. Anybody on Twitter right now? Anyone? Anyone? Yes. Okay. Fire off one of these hashtags. Are we ready to go? Yep. Fire off one of those hashtags and let's see what happens. Oh, Tom Mulcair. Oh, we got some liberals. Ooh, Stephen Harper. Nobody tweeted a conservative hashtag.
I think the problem is we're short on links here in the building, and
Sure. Yeah, sure.
one has to drop out. So
This fish has lovely hair. So we have, oh, there we go. So we have some hardware here that's swimming in the water. Over there, we have data, which is the tweet that's going to the fish. That's happening over Wi-Fi. There's software, which we're going to get to in a little bit, and we're going to have some design exercises about. And these fish, of course, have to be able to sense the tweets that are coming in. So all of those components and factors that we just talked about are embodied in these cute little political fish. That is a very simple way of looking at the Internet of Things. We all know that it can be orders of magnitude more complex when we start looking at some other applications and some other problems that are being solved. When it comes to designing for anything, we have a certain philosophy around design, and that philosophy is based on understanding who we're designing for before we start designing. Why do we have blinky internet politician fish here? What is the purpose of those fish? You guys are quiet. Is it too hot? So we can see them, right? It's a demonstration. We really have a problem, I think, in technology where we build things because we can, as opposed to building things because there is a need. My philosophy around design is really understanding the need and building towards that need. That's based on a principle called Bailey's human performance model. And if you've done UX or you've studied psychology, you may have come across this before. There are three main components in Bailey's human performance model. There's a person, there's a task, and there's a thing. Not that, no.
I wish.
Kevin is smart, but not that Bailey. So Bailey's human performance model is not the guy that does the delicious Irish liqueur either. It's got completely other Bailey. The human performance model states that anytime you do things, there's three components that are really key. The human, or the person, the actor, there's the task that they're trying to do, and then there is the environment that they are doing those tasks in. Designing for IoT means really understanding these things. Why? Well, first of all, we're designing for very big markets, very different markets. Traditionally, when we were designing technological products, especially stuff that is meant for mass market, we were very aware of who we were designing for. And whole industries have sprung up around that. So things like market research, and if you're more UX, user research, usability testing, things like that. Understanding the environment and understanding the task is a little bit more foreign. We're not as good at those things, There aren't really large industries around understanding tasks and understanding contexts, although I think there should be, personally. When we understand the person, the task, and the context of use, we are in a better position to design something that is useful, that is usable, and that is enjoyable. Little pop quiz. How many people do UX here? I'm going to put you on the spot. Wow. Cool. We're among friends. What is the definition of usable?
There's nothing better on the market. And I'll put up with it.
That's the definition of gold mine. How do we define usability? A VCR that your grandmother can figure out. So you and I are probably of the generation of the flashing 12, right? And if you've never used a VCR, so when I was a kid, I would go over to my friends' houses and we'd go to watch a movie, and you'd open the VCR, you'd press a button, this thing would pop up, you'd slide the tape in, you'd close it, play your movie. There's a clock on VCRs, and it's a digital clock. 90% of my friends, when I would go to their houses, the clock would be flashing 12, 12, 12. You know it's true, right? Yes.
Now, from a hardware point of view, it was a great time.
Maybe for you.
Now they come up on Netflix, right? Killed the whole market.
So the reason that the clock was flashing 12 is because nobody could figure out how to program the damn clock on the VCR. Now think about it. You have these devices that are great. You can watch movies on them, but you can also record movies, and when you're away, you're supposed to be able to program your VCR so you can watch Falcon Crest and Dallas and Knots Landing, right? When you're gone. But nobody could do that. Think of all of the functionality of the VCRs that couldn't be used because people couldn't figure out how to program the clock. That's a usability problem. I love your definition of usability. How do you define usability? Discoverability and feedback, yes. Uh-huh. Okay, so discoverability and feedback, those are really important aspects of usability. When I push this button, what happens, right? That's really important. We're going to talk about some of those principles, some of those core principles in a little bit. Have things gotten better or worse in terms of consumer electronics since the 80s? Way better? Better and worse? I saw a Samsung TV the other day that had no buttons on it. We spent 15 minutes trying to figure out how to turn it on because there was no remote.
Cost decision on the hardware side.
Buttons are expensive, apparently. All right, so have things gotten better or worse? It's debatable. Once again, what's the definition of usability? The ability for a person to accomplish a task in a certain environment. Are you Googling that?
Thank you, Wiki.
No, no. The ability for a person to accomplish a task in a certain environment. Naturally intuitive experience. Jen? A way to accomplish your task in a way that's efficient and enjoyable. Absolutely. So multiple times. That enjoyable factor has to be repeatable. All of those things. I saw another hand, Alvaro. Mm-hmm. Okay, so the comment was it doesn't have to be enjoyable. I should be able to go to a bank machine anywhere in the world, put in my card, get my money, and not really think about the experience, right? I enjoy getting money. Accomplish a task without training or errors, right? Every single one of those VCRs in the 80s came with instruction manuals. Who read them? Katie. You read them. You liked Falcon Crest that much. Yeah. So it's important. All of these things are true. We have to be able to do things. We have to be able to do them repeatedly. We have to enjoy them, or maybe even not even notice them. Some of the best experiences are experiences where we don't even think about what we're doing because things work in the way that we expect them to work, and it just doesn't even register. So that's what we do for a living over at Akendi. We design stuff that people really shouldn't even notice. Yeah. I find it rewarding. So all of these definitions that you guys have come up with are absolutely right. I'm gonna tell you sort of the dictionary definition of usability, and that comes from the ISO definition. So the International Organization for Standardization defines usability as a specific user being able to complete a specific task in a specific context of use with effectiveness, efficiency, and satisfaction. So if you break it down to those three components, effectiveness, efficiency, and satisfaction, that defines what usability actually is. But to get there, that's the end point. In order to get to that effectiveness, efficiency, and satisfaction, we have to understand who that specific user is, what that specific task is, and what the context of use is, which is kind of challenging in an IoT world. Wouldn't you say, Kevin? So why is it challenging? Well, we may come to a time where we don't know where the sensors are, what they're embedded in. We may come to a time where we're interacting with things that look like chairs, that look like knives and forks and plates, but they're really computers, right? So that understanding that you mentioned about understanding what something does will be challenged. We're also going to be dealing with a time where that context of use is going to change. Already, when we're designing for mobile, we're facing that problem. How many of you are working on mobile apps, mobile websites, or mobile solutions? That's a good chunk of you, right? How do you predict that context of use, that environment that your users are going to be in? Well, you're not designing for a specific environment, you're designing for all the environments, right? And this is what makes designing for IoT that much simpler. I remember back in the day, when I was young, this thing called the internet. It is, you see, a series of tubes. That information flows through. Now, back when I started using the internet, my browser only supported text, right? And believe it or not, to connect to the internet, you had to hear this little sound, and it was kind of like beep, boop, shh, boop, beep, boop, shh. And that's how you knew you were connected, right? In that time, the internet was kind of a one-way street. And the information flowed out of my screen towards me, and I consumed it. Unless I was coding a web page, I had no real way of influencing what I saw on the screen. That was the first iteration. Then this magical thing happened. It was called Ajax. And people started to be able to change the content that they saw on the web. They started to be able to interact with it in different ways. And the problems of web usability were not about just mitigating the flow of content towards people, but also making it simple and easy for people to add content to the internet. Suddenly the internet was a two-way street. Was that Justin? Justin just went off. I'll talk to you a little bit about peripheral vision later and how flashing things are distracting. What about the Internet of Things? It's not a two-way street anymore. Anybody ever been to Paris? Les Champs-Élysées, you ever drive there? Yeah? It's not really a two-way street. It's just kind of this mélange where you throw yourself in and you drive around and around and around and around, and hopefully, if you're lucky, you can get out again. right? The Internet of Things is more like that than it is a two-way street. It's certainly not a one-way street. Because not only are we consuming data, but we're creating data. Not only are we consuming and creating data, but we're sharing it with each other. Our devices are sharing it with each other, and it's all in this cloud and it's raining down on us. It's raining data. How do we make this easy to use? That is the question. These are some of the things we're going to answer in a little bit. Before we do so, do you want to talk a little bit more about some of the hardware challenges when you're designing?
Sure, I'll brief on a couple of different types of end internet connected. Do you have that web page that would
I do.
let us look? So the fish here are receive only. They're looking at the
Bear with me.
internet for any hashtag that comes along that happens to match this hashtag, and they then can turn their lights on based on that. I'm sorry, yeah, so we talked about sensors. I've been using that term fairly loosely, but there's a whole bunch of things that local hardware electronics can do. There's a whole world of... the question was, we talked about sensors only and what other, there's other things that the end devices could be doing other than just collecting data. And the answer is absolutely. Remote communities, sensing change on pipelines. There's a whole commercial aspect to this Internet of Things that's going to make it easier so someone doesn't have to drive in a truck 40 miles to check to see if a generator is still working. That's done regularly. There's drones that'll be going out and looking at information, sending that real time back to places. So this general sense of a sensor, it can be a very complicated hardware device like a drone with full camera equipment and air sensing equipment, or it could be something much simpler like a temperature. But they can get very, very complicated, and they can send a lot of data, and they can be interactive in both directions. They can be guided remotely by the far end. There's lots of opportunity here, and that's going to make up the, somebody probably has better data than me, but I think the number out there, for argument's sake, is 100 hardware devices per person in terms of what's coming, and all those things on average. So there's a lot more complex things and lots of little simple things that are going to provide data back to us. Any other questions? So Dom's been working hard at, so this is a piece of, again, this is a really simple device we put together quickly. This has, it's not the Arduino-based stuff. It's a little more complicated. It's a little more production-oriented. But this will send real-time data. This is freeware. So we've just downloaded this freeware, and we're able to send our data and demonstrate it from the cloud.
Yeah. So this is an example of some of the data that's coming down. We're going to play with this a little later once we get rid of those pesky developer people.
Just we'll have this over if anyone's interested. But on the left, the chlorine level is somewhere between, I think, 100 and 800. The pH level is upper right, and then the temperature is lower right.
Okay. So, when you're designing things for the physical world, what are some of the things that you have to take into consideration? We've got this octopus. It is going to sit in water, right? So, the sensors have to be the right type of sensors. There's a whole bunch of different things that we can put into a device in order to sense the world around us. That particular octopus device is sensing temperature, it's sensing pH, and there's other things that it can pick up. We have phones that can sense acceleration. They can sense, some of them, blood pressure or heart rate using their lights. There's all sorts of different sensors around. So we have to understand, in terms of the physical world where we're going to build something, we're going to build a solution, what it is that we are looking to create sensor-wise. Let's say we were creating an alarm. There's certain things that we could use to trigger that alarm. It could be motion. So we have sensors that can pick up if people are going to move. In an environment, we have sensors that would pick up humidity, for example. If there was a flood, something like that could trigger an alarm back to a device. So that device would need to control feedback, like we were talking about. It would need to alert us to the fact that there was something happening that needed to be attended to. And potentially, we might need to be able to turn off the alarm, like Kevin alluded to, where we not only get information from our devices based on the sensors, but that we put information back into our devices to go to the systems. So when we're talking about hardware design, there's a real need to understand the flows and the possibilities of what we're dealing with. In terms of usability and that human layer that Alvaro mentioned, it really is understanding the tasks in the context of use that people are going to be encountering. How many people have smartphones here? How many people have used some of the new Google applications? Okay. How does it know so much about us? How does Google know so much about us? Big data, yeah. How else? So if you could read the screen on that phone, it would tell you, it's saying right now it would take you about 11 minutes to drive home. How does it know where home is? It's geotagged, right? So these are all sensors that we deal with. When we deal with these types of devices, how do we know what they can do? How do I know what my phone can do? You're shaking your head. We don't. Based on the user interface, so the things that we can see. How else? How do we know? Marketing. We read the ads, we look at the commercials. Oh, I want my phone to be able to do that. How else? We've seen somebody use it. So we're watching other people, we're observing, we're learning. So these are all different ways that we're actually looking at the devices that we're using. How many people have heard about the term affordance? What does affordance mean? Industrial designers, UX people, what's affordance? The design tells you what the thing is supposed to be used for. Yep. Okay, so this is real technical. The capacity between the actor and the object, a door affords opening. Yeah. There should be an entire website called Door Fails. Because it is really, how do you know when to push and how do you know when to pull when you get to that door? Because if you need to pull, then there should be a handle. If you need to push, then there should be a strike plate. But sometimes we get a little clever, right? Sometimes we get real clever and we say, wouldn't it be really cool looking if there was just a strike plate on both sides? Or if there was these cool handles on both sides, and then you have that momentary moment of embarrassment as you're pulling the handle and it's really a push door, and then you kind of play it off like you meant to do that and you were just resting for a second. Yeah, we've all been there. That door has poor affordance. The thing about these phones that we deal with is the affordance that they give us are, it's not necessarily there. We have these sleek pieces of metal or glass or plastic in our pockets, and we look at them, and by looking at them, we can't really understand what it is we're supposed to do with them. So physically, in terms of their design, there isn't a lot of affordance. How about the software? How do we know? How do we know what we're supposed to do? If you're typing something on your iOS device, how do you undo? Are you waving at me? You shake it. How did you find that? How do you know that? Pardon? She Googled it. Your wife was so frustrated. Well, that's last resort, right? How many people didn't know that you can undo by shaking your phone? Don't be shy. See? That is the same kind of affordance fail as the door. So we're designing for things that are sleek and sexy and cool, but they have very, very limited affordance, not only in the hardware, but in the software. So that question about, are you going to try it? Are you going to try it? Careful, the floor is concrete. The question is, how do we design things that are easy to use, that people actually understand how to use? Well, again, it goes back to understanding those people, understanding their tasks, understanding those contexts of use. We want to be able to do that. It works? He tried it. He was shaking his phone. That was pretty cool. So we have this idea then that once upon a time we used to design for transitions. When buttons were visible, when we had a lot of what we call visible structures, we would design for transitions. We would design to get people from starting to ending. We would design for these paths. We would design for novice users. We would design for intermediate users. We can design for advanced users. Now, generally, what we call the hidden structures are reserved for those advanced users. But now we find that in design, we're not making that distinction between the novice user, the intermediate user, and the expert user. We're throwing people in. If you find the feature, great. If you don't, too bad, and you're stuck having to Google, how do we undo things on an iPhone? So what we want to do is understand this relationship, because there's this idea of expert users and novice users. When we're designing these connected devices, not necessarily so. So throw that out the window. We want to be able to understand also about this idea of small structures and invisible structures. So invisible structures are things like the undo on an iPhone, where there is nothing to see. There is nothing to give me a clue about that functionality. There is no affordance. So those are invisible structures. Remember that. There's also this idea of small structures. When you rent a car, how do you know what side the gas tank's on? Arrow on the gas tank. How many people knew that? 50%, if that. You knew that? You knew that. He designed stuff.
Found out after I had a rental car, and I just drove me crazy. I had to figure out how to get this what side on, and it was just in a rush.
You do the circuit of the gas station, right?
One of my staff said, "Did you know there's a little thing?" And I said, "Are you kidding me?"
Yep. There it is. Small structure. It's not invisible, but it's so small that most of the times you miss it. Again, this is something we deal with in terms of design. A lot of the times we're looking at little tiny structures, what we call micro interactions, that give people clues and cues about what we do. But those invisible structures, those small structures, those are challenges that we deal with. How about multimodal interaction? Anybody heard of that? What does that mean? Yeah, so there's many different ways of interacting, through touch, through gesture, through voice. This is the Ecobee Smart SI, just a little plug. In case you're interested, there's going to be a draw tomorrow. We're going to be giving away one of these. They're a connected thermostat. They are precursors of, and dare I say, a much better interaction than the Nest. We just happen to have helped design it, but hey, I'm objective. So what do you notice? Well, there's the Ecobee. There's the thermostat itself in the bottom left-hand corner. Then we got a tablet and a phone and a very dark interface that's hard to see. And then we got a browser interface These are all interfaces to control the thermostat. Do they look the same? No. Why? Why not? That's an equally good question. Why or why not should they look the same? Why not? They are different. We're going to give you a robe and a stick and put you up on a mountain. You're a prophet. It makes no sense because it's a completely different UI. There's different interaction modalities, right? There's different ways of interacting with these different things. So why would the interfaces look the same?
Is there a marketing guy in the room? Is there a marketing person in the room?
Oh, there's got to be. Yeah? You're marketing? He's not going to admit it, but he's marketing.
Okay, so I'll argue that some threads of similarity might be useful, but from a use perspective...
Absolutely. Yeah, so there's threads of similarity, but there's different things that we're going to want to do, right? On the desktop interface, I might want to track my heating and cooling over time to make some strategic decisions about, should I be replacing my windows? Should I be upping the R value of my house? Versus on the mobile interface, oh damn, I'm on vacation and I forgot to turn up or down the heat or whatever the case might be, versus on the device of itself. So understanding the modality and how you're going to interact with the device also helps us understand the types of things we need to be able to do. So these are all sort of interaction design things that we need to take into consideration as we're looking at the design of IoT devices. Use needs to be intuitive, not just intuitive, but hyper-intuitive, because we have these small structures, we have these hidden structures, these invisible structures, we have multimodal interactions, we have interactions across devices, we have interactions that require other interactions with other devices. All of these things are realities for us as we're designing. What is that? Here's a hint. It is not a macaroon. Motion sensor, sorry? A hockey puck? It's a very expensive hockey puck. Pardon? No, it's not a beacon. It's the ship from V. We have an 80s television theme running through this talk. It is none of those. This is an activity tracker, so it does have a motion sensor in it. This is an activity tracker. What do you do with it? It's called the Misfit Shine, and it tracks your activity. How do you know what to do with it? Does anyone have one of these, by the way? You do? It's sitting beside your computer at home? Well, there's a whole debate about whether or not activity trackers are actually useful. You could probably, you'd never forget it if you swallowed it, right? But you might have to keep re-swallowing it if you know what I mean. That's, but it's really quite nice to look at. If I could do a Johnny Ive impression, I might talk about the chamfered edges, and that's important when we talk about the satisfaction aspect, how it feels, how it looks, the visceral reaction that we have. But if you'll notice the definition of usability, we talk about effectiveness, efficiency, and satisfaction. And satisfaction is sort of the last of the three things that we mention. First is the effectiveness and the efficiency. Effectiveness means, does it do what it's supposed to do? Does that do what it's supposed to do? Aha! What the heck is it supposed to do? We don't know if it does what it's supposed to do because we don't know what it is. So that's part of the problem that we're facing. It does do what it's supposed to do. There are lights on it that actually light up when you get close, as you get closer to your goal. But there are no buttons, there are no levers or knobs. You have to interact with this through your smartphone. You have to set your goals, and there's much more data that it sends out to your phone. So the way the data is visualized, it's visualized in a very simple way on the device, and it's visualized in a much more complex way off the device. Same thing with the octopus and the fish. Oh, somebody just tweeted about Tom Mulcair. Tom Mulcair, very simple interaction, very simple feedback on the fish, but if you were to look at the interface of the application that you might build around it, or for the octopus, it might be a lot different. So part of the problem for designing for IoT is that we're not only designing one interface, sometimes we're designing multiple interfaces for multiple different situations. This is a favorite one of mine. This is one of my watches. How do you change the time when, let's say, you go to a different time zone? How do you do that? I wrote a whole blog post about this, by the way. You have to clap? No, you don't clap. Do a little dance. you turn your fingers around the watch face? Well, you're close. Actually, the face of the watch is touch sensitive. So if you tap it twice, it will tell you the hands of the watch will rotate to the time your alarm is set for. But that is not how you change the time. You're close, though. If I was giving out prizes, you'd get like second prize. How do you change the time? Long press? Okay. The fact that you said long press, it's good, but it's wrong. The numbers? No. That's actually the right answer, kind of. So you're close, you're the closest. So the answer was, you don't set the time. It's an ironic hipster watch. The hands don't move at all. No, I'm joking. I'm joking. So you don't set the time. That watch has Bluetooth in it, so it communicates with the phone. So when I get off a plane, my phone talks to a satellite, says I'm in a new place, some information's beamed down, it updates the time on my phone. My watch then talks to my phone to say, hey, what's up? And my phone says, we're in a new time zone. And the watch says, cool. And the hands just change all by themselves. That's cool, right? Except when you think that that's a watch. It's not even a digital watch. It's an analog watch. So if I were to hand you an analog watch like this and say, set the time, you're not necessarily thinking, well, let me run and get my phone to do that. That's what we call a mental model. It's around the expectations that people have when they're dealing with certain devices and certain types of technology. So in order to make sure that things work, like we discussed before, in the way that we expect them to work, we also have to understand those mental models. We have to understand what it is that people expect to happen. So in terms of how we do that, there's a lot of different ways. Let me show you a couple more examples. What's this? Outputs. They are outputs. So there's wavy lines at the top. There's a histogram in the middle, and then there's sort of square, weird 1980s type plotter lines at the bottom. What are we looking at here? Anybody have an idea? It does. It reminds you of biorhythms, right? So that's the thing that I swallowed earlier. No, we're joking. No swallowing of things. This is output from oil rigs. So there are 6 oil rigs as represented by the 6 different colors that you see at the top and in the different graphs. And these 6 oil rigs actually output data. Now, they output data every 60 seconds. Once a minute, they output data, and they output 3 things. So the top thing is the flow, so it's the rate of flow. The middle is the voltage, and the bottom one is the load. So flow, voltage, and load from these oil rigs. So these 6 oil rigs are outputting data once every 60 seconds, 24 hours a day, 7 days a week. That's a lot of data about oil. So this illustrates another challenge that we face, sort of a third real fundamental challenge when we're designing for IoT. What to do with all that data? How to present it in a way that makes sense to people, that they can use, that they can digest, and they can act on. So, what's important? We talked about a bunch of things. We talked about fish, we talked about devices, we talked about hardware, we talked about software, we talked about interaction, we talked about invisible devices, invisible structures, we talked about small structures. What's important when we're designing for IoT? 3 things. There are 3 things I want you to take away, 3 things that I think are really important if you're designing IoT for that human interaction. One is context. Understand where these interactions are going to happen. Understand how they're going to happen. The next is scenarios of use. So depending on your background and where you come from, you might call these different things. You might call them use cases, you might call them user stories, we call them scenarios of use. Understand what those are in a real deep way, because those are going to inform the types of interactions that people have and the types of mental models. Speaking of mental models, the third thing, understanding the users and their needs. So really, we want to focus on those 3 things. We want to focus on the context, we want to focus on the scenarios of use, and we want to focus on understanding the users and their needs.
What's your opinion, Dom, in terms of scenarios of use? How many do you really need to sort of get your team, design development team around a particular use? You need 3, 5, 10? Mm-hmm. What gets most of the design sort of thought through from an ease of use scenario?
As you know, Kevin, I am a consultant, and all consultants answer all questions with one phrase: it depends. It really does depend on a couple of things. It depends on how many different types of users you're looking at. So different personas. On a per persona basis or a per user type basis, if you are not looking at sort of a minimum of 3 usage scenarios, then you're only really scratching the surface. Question? Do I want to expand on context? Absolutely. So when we think about context, we think about physical environment, right? Am I in an office with a T1 LAN connection? Well, I'm speaking about my experience with a big screen. Or am I on the bus with a 3G connection and a 4-inch screen? Or am I running and trying to figure out how far I've been? So context is about that environment, what we call context of use. But it's not just the physical environment. Sometimes it can be the cognitive environment. Are you being harassed constantly at work? Is it noisy? Is it bright? Some of those things can also affect how we use things, and we can help solve problems of context in the design if we understand them. So can I tell you a little small story? Years ago, we did a usability test on a physical device. It was a power cost monitor. It was it was a little thing that you put on top of your electric meter, and it had a little infrared eye that would count every time the disk would rotate. And then it would beam that information to a little battery-powered display inside the house, so you could tell in real time how much electricity you were using. This was for a company called Blue Line Innovation. I think you can still get them from like Ottawa Hydro. I think they had a program last summer. Anyways, you put the reader on your electrical meter. It has to read 3 revolutions of the disk to line up. The first prototype that we did the usability testing on had an audible cue when it read 3 revolutions of the disk. So 1, 2, long beep, beep, I'm good. So we were testing it see if people could understand how to set it up, how to install it. Great success, great success. We went to one particular person's house, and as we were setting it up, this person's neighbor starts up their lawnmower, starts mowing the lawn next door. So, one revolution, two revolution, all we could hear is brrr. We had no idea because the design only had an audible feedback cue. So we go back to the designers and we say, well, the context is very unpredictable. Some people's meters are inside, some are outside. Audio is not, it shouldn't be the only modality in terms of feedback. So we put a light and a sound. So the light would flash, and it would flash to indicate battery power, and then once it picked up 3 revolutions, it would stay on solid red for a certain amount of time. We wouldn't have necessarily understood that if we weren't doing research in different contexts, right? So context is really important to understanding how things are going to be used and how we need to modify designs to overcome contextual problems. I'm sure you have a ton of context-related stories in terms of design issues.
Absolutely. Our very first service we offer people that are trying to figure their way through that is concept design, where we use, if it's Arduino or other, we use something to get the user experience understood in whatever way we can, because developing the product at that point doesn't make sense. So we do a very quick creation of the objects, the interfaces, to allow the interaction to happen, so we understand then what we need to put into the product development that makes sense from a use perspective. And then we move on to detailed engineering and through to production.
Absolutely. So context, scenarios of use, understanding the users and their needs. Those are really the 3 things that we're going to focus on today. So in terms of the context of use, the problem, the solution is ethnography, contextual inquiry, experience mapping. I'm trying to decide, should I ask people if they understand those terms or if they've never heard of them? How many people have never heard of any of those things? Well, that's good. Don't be shy, like seriously. Okay, so ethnography, it's a research methodology that we borrowed from anthropology. So Jane Goodall, Diane Fossey, they would go to the jungle, they would hide in the bushes, they would watch the gorillas and the chimpanzees do what they did. That's ethnography. It's really hiding in the bushes and watching people. Although we tend to obtain consent because otherwise it's just stalking, and that's illegal. But it's watching people work in their own natural environment so that we understand some of those contextual cues that they may not always be able to articulate, or they might not think of articulating. So by watching people work in their environment, we can really understand some of those contextual issues. Contextual inquiry is very much like ethnography, except instead of just watching, you're allowed to interact with the people that you're observing. You can ask them questions, you can probe, you can dig deeper. Experience mapping, this is an output. An experience map is really once you understand the usage scenario and the tasks, can you actually create a map that illustrates that so you can pinpoint where there are problems and where there are gaps in that user experience. So those are the things that we tend to do to try and solve this question or this issue of context. In terms of understanding who the users are and what their needs are, we also want to look at personas, usage scenarios, experience maps also. This is really a hierarchy. So a persona is a representation of a user. You guys build products, you have services. How well do you know your end users? It's a rhetorical question. You don't have to answer. But how well do you know them? Do you know them in great enough detail to be able to predict their needs and what it exactly would satisfy them in a design? The personas are the first stage because they deal with the actual users. The storyboards and the usage scenarios, that's what the users do. And both Kevin and I will tell you, we can't really design effectively unless we know who we're designing for and what it is that they're doing. And a lot of the times we kind of say, well, this makes sense to me, and I'm an engineer, or this makes sense to me and I'm a software developer, so it's got to make sense to Joe Blow. Well, I have news for all the people in the room. We're not normal, right? We're not average, everyday users. If this was the case, if that kind of mentality worked, then we never would have had the flashing 12 on the VCR. So what we really need to do is take the time to develop the personas, develop the usage scenarios, and the experience map is what happens when we string a bunch of those usage scenarios together to really represent the end-to-end life cycle of one of those personas using our product or service. So the experience map, it catalogs everything from unboxing, setting up, using, right through to recycling, getting rid of, and starting the hunt to buy another. It really is the full cycle of use across the life of the product.
Absolutely, including installation and maintenance.
Yeah, and these are things that we don't often think about, right? So, you know, it might really be easy to use, but is it easy to set up? It might be easy to set up, but is it easy to tear down? I am notorious. I'm absolutely notorious for forgetting passwords, right? So things like my router, things like my Netflix account. Oh yeah, it's great, it's easy to use, but when I have a problem, oh no, now I have to scrap everything and start over again. If you really look at the experience map, then you'll understand that full life cycle and be able to design for it.
And with the IoT and the connected world, the whole idea of preventative maintenance is going to really explode in terms of what we can now do with objects to reduce the downtimes and the frustration problems as people try to get involved to try to figure things out. With data, we'll be able to manage that quite a bit differently than we have.
Yep. So, just in conclusion, we want to be able to look at users, their tasks, and their goals. We want to be able, as designers, to understand the technology that we're working with. And a little bit of advice, think about your desired outcome. Think of what you want the end state to be and work backwards from there. A lot of the times we start with an idea and it evolves and it grows and it kind of gets away from us. But think about what we need to do and what we need to be, and move towards that. Move towards the starting point backwards from the desired outcome. So something's happening over near the juice. We're going to wrap up soon. Before we do, I want to open the floor to questions. Then we're going to take a little break. We're going to let you guys go get some snacks. Then we're going to come back. If you're part of the development workshop, like Adam said, you'll go through the robot zone. What happens to you in there? I don't know. Hopefully it's a good thing. We'll trust that you're in good hands. The people that are part of the design workshop, come back here after you've had your snacks, and we're actually going to look at some personas. So we've created some personas for you. We're going to show them to you. We're going to give them to you, help you understand what they are. And then I'm going to ask you guys to design some solutions for the personas based on this octopus. Right? So we're going to fire up the octopus. We're going to show you the data outputs, and you're going to design some real solutions for some personas, for a mobile device, for a desktop device, for a tablet device. So, any questions before we wrap up? None. Okay. I mentioned snacks. I probably should have not.
Before we jump, could I show of hands, how many people have children under 18? Over 18 and in some form of post-secondary university education? There's a real opportunity here. You may all be aware of it, but the schools are really starting to integrate and adopt into their tech classes the Arduino-based programming, the 3D printing. I encourage you to get on board with that. If you're interested in getting more involved, come see me. I know the community in terms of what's going on, and there's a tremendous amount of opportunity for our children to learn. They're the next generation that's going to be taking some of the knowledge we're learning here today and moving it forward. And my goal is to take my 20 staff and move that knowledge into the community. We'll be putting some of these maker bots and things up online so people can download and start getting interactive with them. in a week or two, your children can be doing things with a little bit of instruction. So I do encourage you to get involved.